In our simulation class, we're going to talk a lot about stress, strain, and the relationship between stress and strain. So it's important to understand what some of these terms mean before coming to class. So what is stress? If I have a slender beam and a thicker one, and I put them under the same load, let's say 100 pounds. Same force on them, but which one has more stress? A or B? If you said A, you'd be right. Depends on the cross section though. If we take a look at the cross section of A, let's say maybe it looks like a rectangle. 1 inches by 2 inches, obviously not to scale. And then this guy, if I look at its cross section, let's say it's a square 2 inches by 2 inches. So you can see that the force is distributed over a smaller area than what this force is distributed over. If we actually want to quantify the amount of stress we see in both of these examples, we take the force divided by that area. In this case, our area is 2 square inches. In this case, our area is 4 square inches. So taking these force divided by the area, 100 divided by 2 square inches, we see 50 psi, pounds per square inch. On this side, we see 100 divided by the 4 square inches. So 100 divided by 4, 25 psi. So quantitatively, this one has double the stress of that one. Stress is a concept that we use to determine whether or not something is going to yield or break. Many materials have a defined yield point, such as steel. Certain steels in our database might have a yield strength somewhere around 620 megapascals, or equivalently 90 KSI. So it tells you that if the stress reaches 90,000 pounds per square inch, this material is going to yield. So stress is very important to make engineering decisions on whether or not your structures are going to yield or fail. Now, in this case, I've showed you axial stress. Other simple examples of stress: bending stress. If I have a beam and I bend it. A lot of times what we'll do in order to visualize what's going on inside of the structure, we'll section it. We'll look at this side of the beam and we'll see what is the continuum of the beam experiencing along this section. On the top, I would expect it to be in tension. If you're bending something, it puts the top in tension. On the bottom, we likely see compressive stress, stress in the other direction. And so it varies from section to section. Frequently, we'll assume linearly. For a simple beam like this, it should be linear. Also, torsional stress. We have a shaft, cylindrical shaft, and put a torque on it. If I look at its cross section again, maybe I'll look at one of this section here, we'll see that on the outer edge, it has high stress. It's twisting it. Of course, I've got the arrows going the wrong way, depending, I guess, which way I'm looking at it. And as we approach the center, the stress in the center is very low. So just looking along this little line here, we see what that stress profile looks like. Now, of course, in real structures, you're going to have some combination of axial loads, torsion, bending, shear, and so this is why using a tool like SolidWorks Simulation is going to be able to account for all of those different types of stress, and then we'll make design decisions on whether or not things will yield based on that.